So this is the second video on sexual selection, and what we're going to look at this time is the 4 models of mate choice. And so you can see them in the picture on the right. We have genetics being involved, kind of that proximate cause. And then we're going to look at some ultimate causes that are surrounding. So in this video, we will look at the first 2, the direct benefits and the good genes. And then in the next video, we'll talk about the runaway selection and sensory exploitation. So we'll start with direct benefits. And so we've already talked about it and just didn't call it that. A direct benefit would be a nuptial gift. We saw that in the balloon flies in the previous lecture, where the female will get a balloon, and some of those have food in them. Some of even the earlier balloon flies would actually just give food. Which is what you see on the right-hand side with the scorpion flies. The scorpion flies have not developed that balloon, but they do bring prey items for the female, and that actually increases success. And then on the picture on the bottom right, you can see the arrow, and actually it's a little hard to see in the picture, but he is bringing a fly of some sort to the female. It's in his mouth. So what they find out is nuptial prey size makes a difference on how long they get to copulate, which increases their chance of having kids. And you can see with the nuptial prey size, it increases greatly at the beginning on duration of copulations. But there's a balance out. You can see it kind of, the curve flattens. There's a point where it becomes too big, or it doesn't get you anything more. All right, so good genes and mate choice. Pronghorn. This is a picture of the pronghorn on the Carrizo Plains up north. The males really don't do anything to attract the females, and what happens is the females will choose males on their ability to defend the harems. So they will have a male with multiple females, and so females will kind of jump around and join a group and stick with that male if he's able to defend the harem effectively, and if he's not, then he will leave. And so it turns out the males with the larger harems are the ones that typically have offspring that survive better. And so the females are really looking for mates, again, that have the ability to protect large harems. And the theory behind this then is they are a very strong male and they have good genes. And we also see that in birds especially, and there's something called the Hamilton-Zook hypothesis. Last test, we introduced Marlene Zook. She used to work at UCR, and she's moved to University of Minnesota, I believe. No, not Minnesota. I forget what school. She's back east now. But anyway, what you're seeing here is the coloration in birds, and what they came up with is it is the lack of parasites that actually allow these birds to get the brightly colored. So a healthy bird with very few parasites are brightly colored. So the peacock below, you see the massive tail with all what they call eyes on it. That is very attractive. A male with lots of feather lice, that tail would be a duller color and there would be fewer eyes. So their idea here is that, again, the females are watching, and if you're sickly, you can't have good genes, and I do not want to pursue you. And then MHC and good genes. MHC is the major histocompatibility complex. This determines how many genes you have to fight off diseases, disease resistance. It's about your immunity. These actually detect what belongs in you and what is foreign. So white blood cells, things like that. And they think it's an honest indication. So again, stickleback, it has to do with color. The one that's more brightly red is what the females will actually go to, and they have fewer parasites. And so they've done lots of studies, and again, the females really prefer the males that are more brightly colored. And they've actually filtered out that red color, and then the females stopped choosing. So although they were brightly red, if they had a way to remove the way the females saw that, then they would not pick that male. And then MHC and in humans, and we talked about this one before, the sleep in a t-shirt for a couple of days, and then they handed males and females t-shirts and asked, who do you think is the sexiest? It turned out that the females preferred MHCs dissimilar to their own, and the thought process behind this is that the females were actually choosing males that are different, so that that combination after sex, that hybridization, if you want, would allow their children to have a more robust immune response, and then obviously a better survival rate. And we will stop the share and stop the recording.